Okay, here's the title, Lesson Learned from Compose. Can I? Yes. So I'm Josse Hyrkkanen. I'm software developer at Elisa, working in a team called Elisa Kirja. And that's we are developing a digital and audiobook service. And that's one of the largest of a kind in Finland. So we have background like over 10 years at least building the service. I have joined like 4 years ago into this team. So has been a lot of development before I joined, and last year we got the opportunity to start a new project for the Android to make things better and maybe discuss some legacy stuff. So one of the choices we choose to have as technology in this project was Jetpack Compose. And that's what we have as a subject for this presentation. Okay. So Jetpack Compose is a modern declarative UI toolkit for Android. So Jetpack is actually a group of libraries that helps the developer do the stuff better, and Compose aims for robust, easy to write UI. And compared to like a previous model of how Android UI have been developed, at least the difference is that it's declarative UI, and compared to this Android view system, it's totally imperative. So the difference is like a big how you implement the UI for Android with Compose. And as it's a modern tech, it's written all in Kotlin. It supports Kotlin features such as coroutines, and that's nice. Also, as a bonus, it's Compose is supporting multi-platform. It's not actually done by Google, but the JetBrains that is also behind the Kotlin language. They have brought the support for multi-platform as well. I don't have much experience about the multi-platform development with Compose, but it's just like a nice to know. And we aim to more like in Android development in this presentation. So what's the Composable? It's just a plain top-level function written in Kotlin with the annotation of Composable. So it doesn't belong in any class, or it doesn't return values. It's just a function that you can call. It can have like a parameters to change the behavior of Composable. But keep in mind that it's just a function. It can be expressed as a lambda as well, or be a parameter for other composable functions. So yeah, Composable is a piece of component or element in a UI tree. It supports material design out of the box. There's plenty of these material components already available for Compose. And that way you have access for many kind of robust design components already. If you would like to implement a different design system, you're always free to go with your own, but this is also good extra that it supports the design system, material design out of the box. And what I like the theming support compared to previous support from Android theming, that it supports theming quite well. You have a switch, kind of switch that you can change from the light to dark mode, and it hooks up quite nicely in the Compose world. And the dynamic colors is something that came with the Android 12. So basically, user has like a free to choice a color palette, and as a developer, we care about just the tonal choices, how we show the UI. So there's a user have as well like a opportunity to change the UI, how our app looks like. Yeah, the modifier, it's quite commonly seen in Compose. Actually, yeah, the modifier is something that you pass to the Composable, and therefore you can like change the behavior or how it looks like, change its size, make it clickable, scrollable. So that's way how you customize the Composable itself. And as information, you can add accessibility labels, such as test tags for Composable. And the modifier used the builder pattern. So there's in this example piece of code, the padding is called twice, and the background between those calls. So the actually order matters. So end of result would be the text, which is surrounded with the cyan color padding 8 dp, and around that is a 16 dp transparent area. Yeah, the Composables are like a stateless by default. So it's how you change the Composable is calling it with different parameters, and it will run the recomposition again. But with if you need to add the actual state for it, there's like this remember call that actually adds the local state in that Composable, and therefore you can store something to that level. So you're free to pass that forward to the other Composable components if you would like to or not. And the other approach would be like using the view models. If you would like to store state outside of this Composable tree. So view models can store the state, or such as flows that you can collect inside the Composable. So you get the state outside from the Composable tree. And yes, some example, don't try to read it all. It's just a example of how what in the Android view system you would like to maybe use the recycle view if managing a lot of data, such as big list. So it tries to optimize how that data is presented. But noticeable thing here is that there's a recycle view and then the layout XML. So you're kind of playing in the different files to putting the screen together. And with Compose, you can actually put it in a few lines that the lazy column is presenting only the visible items and other that are out of the screen. They're not like included in the compose tree. So that way it's performing well with the big data lists. But like a previous example, I think this much more readable. You focus in the thing that what you want to show in the UI, and that's kind of one of the powers that declarative UI provides us. Previews, one of the nice features in the under Studio. You get to see what kind of screens you want to set there, and you have an opportunity to have a quick preview of the UI that you're actually creating there. So this preview can like be a really small piece, or it can be like one screen, total screen you decide. It's a handy tool for development. So you don't actually need to run the application on a device and then navigate to the point that you want to preview. Tests. Everybody loves tests. Yeah, I think at this area, the Compose makes it easy as well, that you can like isolate the tests to just for this small piece of component that you can focus on. And Compose is making that quite easy, and it runs relatively fast as well. Okay, what's lying under the hood? So when we are compiling our application, the compiler adds something in the compose functions, and there's this composer included. So it goes down the whole compose tree, adds the compose and call every composable function. It creates these with composer start calls, these groups, so it helps it to manage like or identify the state changes, and that way the compose itself tries to optimize its refreshing the whole tree. So if it doesn't need to refresh something, it tries to skip it. So the composer plays like a big role in this part, that it sniffs the like parameters that the function is getting, and what's the end result of it. Yeah, so composition is generating this tree-like hierarchy of our compose tree. So here as an example, the main screen is holding the components under it. So column, row, text. In the row, there's a text and image. And as I said that the composition tries to optimize that if there's no changes, it doesn't call that again, that part. So for example, inside this row, if the image stays the same, so it's using a cached result of it. So it memorized that and can skip it. So it can stay like a performant. Otherwise, if you force to it run the composition from top to end, then we would like to it can like refresh on every frame that it's drawing on the screen. So that doesn't sound like efficient. It's like 3 phases total that Compose runs. Any of these phases are skippable. As said, if there's no changes in a composition layer, then it skips the rest. And if there's no changes in layout phase, it can skip the draw phase as well, and so on. And the composition is something that is creating this composition tree, and it describes what to show on the UI. And the next layout is describing where to show, and draw phase is giving the surface for all of those, like drawing image and drawing bottom borders and putting the colors in. Here's some of the best practices noticed along the way when developing with Compose. That minimize the calculations. So you can expect that the whole composition goes through on every frame, or when you're giving the Compose possibility to skip the frame, that's even better. But when you're doing the calculations, like sorting lists in an alphabetical order, you could make it so that it's sorted on every frame if possible. So here, use those states to memorize the output of that sorting. So if the list doesn't change, then the sorting wouldn't change as well. So if you hold it in a state, it doesn't need to calculate the sorting again. Composable should be free of side effects, such as writing database into database or something like that. You wouldn't like to do that 100 times in a second. Use lazy layouts when you're like dealing with a big set of data, and optimize the composition counts. That's what I told a little bit already. So Composable is recomposing when it noticed there are changes. But one thing that we noticed, that if we are giving as a parameter some our own object, that Compose doesn't know how to compare it to the previous object. It just then recompose again. So it doesn't know that it's the same one. Yeah. The next, avoid backward writes. So that's basically when you're dealing with the states, you're first reading the state value, then write a new value in it. So that's causing like an endless loop of recomposing, and you're not getting out of it. And the last one, I prefer lambda modifiers when using frequently changing state. So so it kind of reflects on this, that when you're creating a modifier, there's like a lambda option as well. So if you pass the modifier further, then when you're reading the lambda, it's actually the place where the value is like taken out from the state. And that matters when we are using state, it's like a place where the recomposition happens. And there's possibility, like a skip composition. What kind of UI is gonna be built, layout, and draw. And that's pretty much it. If you have any questions.